Hi, welcome to the Center of Math's Problem of the Week. This week our problem is evaluate the integral from 0 to 1 and from y squared to 1 of y e to the x squared dx dy. This is a double integral, and with double integrals we evaluate from the inside out. We evaluate the innermost integral first, which would be this. So we'd have to integrate with respect to x first, since dx is on the inside. But if we try to evaluate e to the x squared, we'd actually run into some issues because e to the x squared doesn't have an antiderivative that can be written in terms of elementary functions with respect to x. To make this problem easier, we're going to switch the order of integration in order so that we can integrate with respect to y first. We're going to switch dx dy to dy dx. Since we're switching the order of integration, we need to change our boundary conditions. So we're going to sketch the region. Our x-axis and y-axis. We have y varies between 0 and 1. Y equals 0 is just the x-axis, and then y equals 1 is a horizontal line. And then we have x varies between x equals y squared and x equals 1. X equals y squared is a curve. And if you take the square root of both sides, this line is the same as y equals the square root of x. And we have x equals 1, which is a vertical line. And our area of integration is this shaded area. If you're unsure which area it is between, you can look at our boundary conditions. So x equals y squared should be the leftmost point, and x equals 1 is the rightmost point, and then y is between 0 and 1. So we're looking at our picture, and we want our new boundary conditions. And we can see that x is from 0 to 1. So we can put in 0, 1. Then y is from 0 to square root of x. And now we can integrate. And this problem is much easier to integrate with respect to y first because we can treat e to the x squared as a constant. Once we integrated with respect to x, with respect to y, now we have a single integral, and we can integrate with respect to x. And we have to use U-Substitution. Using U-Substitution, we set u is equal to x squared and take the derivative of both sides, have du equals 2x dx, and then we divide both sides by 2 because we want to substitute x times dx since we want to get rid of this and substitute it. And once we substitute, we have an easy function to integrate. And our final answer is 1/4 times the quantity of e minus 1 plus a constant. Thank you for watching. I hope you enjoyed this video. Be sure to check out our blog, check out centerofmath.org, and be sure to follow us on Twitter and Facebook. Thank you.